Afternoon. My announcement last Friday was along the lines of air conditioning, service, and repair. And we're going to walk through, both Dylan and I, a couple of simple things you can do to look at your refrigeration system when you start it up this spring. How many here have air conditioning in their house? Good. How many here like to pay $150 an hour to have a service tech come out? Somebody else to do it, right? Well, we're going to go over about 6 or 7 of the most common things to look at that could most likely save a trip from the service tech coming out. And remember, when I say $150 an hour, it doesn't include the truck and drive time, which is usually another $100, $100 and a quarter, plus the 60-80% parts markup that they make on a $30 part. So in the end, you know, you'll be lucky $300, $400, $500. So some of you have been there before. Hopefully we can prevent that. We're going to start off with kind of walking through the components of your air conditioning system. Dylan's going to do that, and I think what's important for people to understand is the components that are involved, a basic overview of how refrigeration works. That's going to be important for you to kind of diagnose what the issue is. So having a real general high-level understanding of how your air conditioning works will help you troubleshoot, or if you talk to somebody, you can troubleshoot most likely what some of the simple components are that need to be replaced. This is a split system that you'll see in probably 90% of residential houses. Furnace, A-coil, compressor, condenser. Not to be confused with, a lot of people also have mini splits in their homes. So mini splits, you've got an outside heat pump, and then you've also got either a head unit or you've got a cassette in the ceiling. Bunch of those systems are over at Encore. Those require really a whole different level of troubleshooting that is very, very opposite from what happens with your residential system. And that's just inherent due to a heat pump system that can do both heating and cooling. Your AC system is working with 2 outside components that are, 1 outside component and 2 inside components that are doing your basically phase change in the refrigerant. So with that, I'm going to have Dylan go ahead and just walk through the 3 basic components. Dear. And then Dylan's going to also do kind of a walkthrough on the refrigeration cycle of how your refrigerant moves through the system. And again, a big part of this is just being familiar, having a high-level overview of maybe what's going on with your air conditioning as you turn it on this year or the following year, or maybe it's making goofy noises. So.
Yeah, so I mean, generally, well, I guess we'll get to this in a second here. So I mean, this is your furnace. This is where the main blower is going to come from. So like the main blower that just blows all of the cool air around your home. And this is your A-coil. This is where your cold air essentially comes from, if that makes sense. So the warm air from the condenser coil kind of goes across the A-coil to cool down, and then after it passes through the A-coil, it gets really nice and cold. And so this is your A-coil, and this kind of just sits right on top of your furnace and then just blows air up through it. And then this is your TXV, which is like the metering device kind of thing. It kind of keeps the low and the high pressure refrigerant away from each other. And so then this is going to be your condenser, and this sits outside your house, and this blows just hot air all the time whenever it's running, because all of the warm air that gets sucked in from the inside of your home just gets exhaled basically outside. So it all goes through here, and there's a big old fan inside here, just blows it all out. And this is essentially like kind of that phase change in the refrigerant that goes through. So this is that condenser, and then there's a compressor inside here that essentially pumps all of the refrigerant around the entire like system of function, I guess. And then so here we can come to our diagram. And so our compressor is inside here, and that pumps all the refrigerant in a gas form through the condenser coil, which is right here as well. And then there's a big old fan in here that kicks all of that warm air outside, and then it kind of goes through that phase change inside here from a gas to a liquid. And then it comes down through here, all the way through this liquid line here. So there's the liquid and the gas line. So from the A-coil, there's a liquid line going in, or a gas line going in, and then into the compressor, gas, and then it changes from a gas to a liquid, out the liquid line, and then it goes through the TXV metering device, and basically the TXV, or the, I guess this is going to be the, yeah, this is the TXV. So the TXV, it just keeps all the high pressure and the low pressure kind of away from each other, kind of make sure that like the system doesn't blow up, essentially, kind of.
How does it change from gas to liquid?
So the changes from a gas to a liquid in the condenser, because it's just kicking out all of that hot air, and so when it comes into here, it's really cold, and so
Yep.
Yeah, is it? Yeah, when it comes into here, it's really cold, and so then the phase change kind of, when it kicks out all that hot air, it just basically blows it all away, and then when it cools down, or when it heats back up, it changes back to a liquid, right?
Yep.
Yeah, when it heats back up, it changes back to a liquid, and then just kind of comes back through. So basically just losing all of that hot air changes it back to a liquid. And then you go through here, and then come back into the evaporator coil, the A coil, which is all in here, which is kind of just a big old A coil with a ton of fins on it and whatnot. And so it goes through here as a liquid, and then it picks up all of the warm air inside your house, and then goes through another phase change back into a gas as it picks up that warm air from inside the house. So essentially it's all just transferring heat. It's not really like losing any refrigerant, losing any of that nonsense. It's more just picking up and dumping heat. It's not like adding cool air, creating cool air. It's just picking up and transferring heat outside. And so then we have our warm air intake, which brings in nice fresh air from inside the house, and then it just goes back through the A coil, changes into a gas, and then goes through your compressor, and then just kind of restarts the entire cycle again. Out to the condenser, kicks the warm air out, back through the A coil, pulls the warm air in, and then just kind of recycles the whole thing. And then as in that phase change, when it pulls the warm air out, it in turn, there's a fan inside the furnace that kicks all that cold air into your home. So as it pulls the warm air out of your house, it adds warm air to your house, or cold air to your house, in that weird phase change.
There's not really an exchange of air, it's just the heat.
Correct. Yep, there's no exchange of air. There's like all the air that's...
Air in the house just going around.
Correct. Yep, so it just picks up the warm air inside the house, goes through the A coil, and then comes back out as cold air, as the A coil is just basically almost frozen, essentially. Just very, very cold.
Radiator?
What was that?
Isn't that like a radiator?
Pretty much exactly like a radiator, yeah, essentially. Very, very much similar to a radiator, because a radiator will take the warm air from your, or the warm temperature from your engine, and then as it passes, as a fan blows over it, just cools it down immediately, and then just goes right back through cooling your engine down. It's kind of the exact same thing as your house. You can imagine your house as being the engine, and then just kind of the A coil as the radiator. But then in this case, we have a condenser, which is outside your house, which is a lot more efficient than a radiator in your engine.
What's the refrigerant that's used in a home unit like that?
This one, I think, is R410A, which is basically standard for what they're all using now, because they used to use R22, which they determined is too toxic for the environment, because if it gets leaked, it'll like destroy ecosystems and everything like that. So they kind of phased that out. You can still technically use R22, but you can't buy it anymore. So like basically what you have on stock is what you have left. So people charge a crap ton for it. But yeah, basically they're all using R410A now, and they're trying to find new solutions for a cleaner, better refrigerant all the time. A buddy of mine actually is, they're in the process of making a brand new one that's a little bit more flammable, but significantly cleaner for the environment. So if it ever leaks out, breaks or whatnot, it's not going to kill very much, if that makes sense.
Efficiency difference between 410 and 22 at all?
There is, but I can't quite attest to that. Dustin, I don't know.
Not too much. No. They've gotten the science down between the refrigerants pretty good. So whether you have a 410A, R22, you're gonna get similar performance out of it.
Right.
But different equipment.
Yeah, and so then now we have the fundamentals down, I suppose. So like a few things you can check for, like when you start up your air conditioner in the summer, in the summer and spring.
All right, real quick.
Yep.
So when your AC kicks on in your home,
Yep.
pulling that air, probably through the little intakes, vents on your.
The return air. Yep.
So is that the same air then that is getting transferred out of the house and out of the?
Condenser. No.
It's all the same air circulating within the house. And what we're teaching our apprentices is that this is what? This is the heat picker-upper.
Picker-upper. Yep.
And this is the heat
Giver-awayer.
Okay, so very simple fundamentals here. Heat picker-upper, heat giver-awayer. So if you go outside your air conditioner, you put your hand over the air conditioner, what kind of air is coming out of it?
Really
Very
warm
hot,
air.
warm air, correct. And in the situation that we're doing here at Lexington Lofts, is we're actually taking that waste heat energy and we're going to recover it in a secondary heat exchanger and we're going to use it to do pool heating. So a system that we've designed, put together, will produce about 71,000 BTUs per hour. That generally just gets lost. And in this situation, we have 2 compressor condensers in the garage. So instead of overheating the garage, it's a perfect application to take that waste heat energy and dump it into the pool. So,
Yeah.
thank you, Dylan.
Yeah.
So I'm going to continue with, again, some very basic fundamentals to make sure everybody's clear. This device here, everybody remember what this is? Good. This is your furnace. Yep. This is your A-coiler evaporator, and this sits on top of your furnace. And then this is our compressor condenser. So it is all one big loop of refrigerant. Does anybody know how often you have to recharge your system, your refrigerant? Never. That is correct. If you have a good install and you have no leaks, then once that refrigerant goes in this system, technically for the life of it, the entire system, 30 years or more, you should never have to put refrigeration back in that system. If you have an issue where you've got a service call and you've gone through the list of things that we're about to talk about, and it's determined that your refrigerant is low, then somewhere in your system you've got a leak. And most generally, 90% of the leaks that are out there are pinhole leaks that you won't ever see or hear, but at about 400 psi, which is what this system will generate in refrigerant pressure, at about 400 psi that's running through that system 24 hours a day, year 5, year 10, year 15, there's the opportunity for what's called micro leaks to occur. And most of the equipment is smart enough now at this point where if it's low on refrigerant, there's enough sensors and safety switches to actually shut down the system to prevent damage from the compressor. Now, with that being said, as your AC system, your compressor is the heart of your system, okay? Everything, it's boxes full of parts that can be replaced. So as we talk further about these parts, we've got basically a list of probably, I would say, the 7 most common issues that you would have with your air conditioner. So we're going to start with those. For example, let's say it's that first 80-degree day of spring, humidity's starting to rise. You turn the air conditioner on, and probably 10 minutes later, you're not really feeling any cold air. Logically, hopefully, you would go outside, check your compressor condenser, and you're looking for a couple of things that could be occurring outside. Number one, you've got this low voltage to high voltage contactor. And you might go outside and you might hear this chattering. And you might be like, oh my God, what's going on? Is this going to cost me thousands of dollars to replace? No. This is a simple electrical contactor. Now, when we talk about serviceable issues or problems when your air conditioning goes down, realistically, probably 90% of that is going to be an electrical component. And it's an electrical component that is built to be replaced. So you walk outside, you got your air conditioning on, but you're not getting any cool air coming out, and you hear this chattering going on, that means that you need a new contactor. It means that your voltage is not holding to suck in that contactor to put line voltage on that compressor condenser. So number one is your electrical contactor. Easy, simple replacement to do. Most parts, most manufacturers, those contactors, you can get those from a parts store. You won't find any of these parts in a big box store or in a hardware store, but realistically, if you've got access or someone in the trades and they know a little bit about electrical, these parts are not hard to source. Most likely, you can get a part number off of any of these parts and you can order it offline. Again, very, very simple parts to swap out and to replace. Obviously, before you would service this or touch this, you would shut off the disconnect, which is the gray box mounted to the side of your house. You would shut off that disconnect, which would disable power to the whole unit. Number two, you go out and your air conditioner, again, is not working. A simple 5/16 hex head chuck, you can remove 4 screws. Standard 4 screws on every manufacturer, every single unit produced in North America will give you access into this compartment. You're looking at, is my contactor chattering? Or we're looking at this device, which is the capacitor. Your capacitor can fail. Your capacitor is kind of like what's regulating your condenser fan that's running. And so you're going to have an easy visual if you've got a bad capacitor, because 95% of all capacitors, when they fail, they bulge. They don't explode, they bulge, and you'll notice right away that the top of the capacitor might be bulged upwards, or the body of the capacitor might be bulged out on the side. Very simple. This has 4 spade connectors on it. It's got a part number on it. It can be replaced. So number 1, contactor. Number 2, your capacitor. Number 3, this one is also fairly common. On top up here, we talked about how the warm air gets rejected from the compressor condenser. So up on top here, you have a fan, a set of blades, and that fan runs on a motor. And so if you go outside, you're not getting cold air, but you can hear the compressor running, but you've got no heat coming off the unit, that's telling you that your condenser fan motor has failed. Your condenser fan motor, unfortunately, most of them are not interlinked with the compressor. So what that means is the condenser fan motor could fail, it could stop running, but your compressor could continue running. So it's a pretty easy observation. As long as your air conditioning is on and you hear that compressor running, but that condenser fan motor is not spinning, then you've got basically a condenser fan motor that gets replaced. And that's not necessarily too difficult too. Again, 5/16 screws around the top of the cabinet, that pops out. You've got a motor and a fan blade assembly that come apart, and odds are that condenser fan motor, it's got a part number on it, it's got a brand name on it, and you can replace it. Now, a lot of these parts, the reason why I like working with Goodman equipment as a name brand manufacturer is that the Goodman equipment line does not use manufacturer proprietary parts. So let's say, for example, if I had a Carrier furnace, or I had a Carrier air conditioner, or if I had a Lennox air conditioner. Now, a lot of those parts are proprietary to the manufacturer, which means often you have to deal specifically with a Carrier dealer repair shop or a Lennox dealer repair shop. You have to deal with their price matrix, deal with their accessibility. Their shops aren't all over town like a lot of repair shops are, where you can get parts from. So with that being said, you are going to find that based on the brand equipment you have, that there are often proprietary parts. I would say probably maybe 30% of the market has proprietary parts specific to the manufacturer. So long story short, again, why I like working with the Goodman product line is that if I go out and do a service job, whether I'm on the north end of town, the south end of town, and I know that the parts inside this equipment, it might be a Honeywell, it might be Johnson Controls, it might be a White Rogers parts, I can drive most likely 15 minutes in any direction find a service appliance repair shop, and I can get these parts off the shelf. So big difference there. A lot of people ask me about brands when buying furnaces or air conditioners. I'm not really a brand specific person. I think that most all of the equipment is made with good intent off of good factories, and most of the time we see install problems, or we see problems related to equipment that really point back to the quality of the installation. So back to our parts. So we've talked about 3 parts there. We've talked about the parts on our compressor condenser, our contactor, our capacitor, and our condenser fan. The 4th one, and I would say this is probably the biggest one to start with. Number 4, number 5 are going to be super easy here. Number 4 are the batteries in your thermostat new or working? Okay? You'd be surprised how many people, it turns out, we just need to replace batteries in the thermostat. So that's an easy one. Check the thermostat. Check and see if your batteries are new. Just put a new pair of batteries in there. They're generally cheap, generally laying around the house, and you'd be surprised how many times that can fix your problem. The 5th one, another easy one, is check your breakers and your fuses. You'd be surprised how many times you can go to your breaker box and find out that maybe that air conditioning 2-pole switch got flipped off. Maybe it got tripped. There's also a disconnect outside, as we talked about, and that typically disconnect has a lid and a cover. It has a disconnect. Sometimes it has fuses in it. Check the quality of the fuses or replace the fuses. So thermostat batteries, checking fuses, checking breakers, another simple, easy way to save yourself a $300 service call. So now we're going to move into a little bit more of the technical parts when you have issues. Beyond parts replacement, then we start to get into the hard part, which is the actual process of refrigeration. And as Dylan explained, refrigeration runs through a continuous loop, the life cycle of the equipment, and it does 2 phase changes. It does a phase change when it hits the metering device. It goes through an orifice and moves from a liquid to a gas. And then as it goes back through the compressor and the condenser, where it changes from a gas back into a liquid. Now, let's say you've checked all those things. You've checked your contactor, you've checked your capacitor, your condenser fan motor is running, you've checked your breaker switches and your batteries. Another thing for you to easily identify is if out on your compressor condenser, remember this is your outside unit, you're looking for on the larger line, this is the suction line. So this is the larger suction line that has a gas in it that should be what industry reference calls beer can cold. If this line is not beer can cold, it is either going to be warm or it's going to have a bunch of frost on it. If that gas suction line has frost on it, then the odds are 95% of the time that your unit is low on refrigerant. And you can run your air conditioning system down to a point to where it will continue to run, and it will run itself almost to the point of damage, but to the point to where you will get visual cues in terms of when you really need to get some service going. So those visual cues, again, as I described, capacitors, contactors, looking at that suction line, that's going to tell you when you see that suction line and either it's hot or it's icing up, that's the point when you've done everything else where you need to call a service tech. Because that's the point where someone has to come out with a set of refrigerant gauges. They need to hook into the king valves, and they need to do actual pressure temperature check on how the refrigerant is running. And most times the manufacturer is going to give you a factory weight on how much refrigerant is put in there. And on mini split systems, if you were to service a mini split, a heat pump, you would have to technically pull all the refrigerant out of the system, and then you'd have to weigh a new refrigerant back in to get an appropriate balance. Because a typical heat pump mini split system, the phase change occurs throughout the line set going to the head unit, whereas in a split system for your house, the phase change occurs right here at your metering device. So, looking for frosting going on, is pretty common. That's low systems. In the last 20 years, in the changeover from R22 to 410A, during those first 10 years, I would say probably 80% of techs on the install got it wrong. And the reason being is R22 as a refrigerant, as a system with a compressor condenser designed for R22, is a hugely forgiving system. You can overcharge it, you can undercharge it, you can block air flow to a certain extent. The R22 systems were also running at a much lower pressure than 410A. Right now, the 410A market for refrigerant is probably about 90% of the market out there right now is 410A systems. There are a few R22 systems out there. And again, back to the performance question between the two, as an industry expert, I could tell you, I really don't see a performance difference in them. What you will see is an efficiency gain in the R410A systems. Efficiency gain meaning you'll get a higher SEER level. SEER is your seasonal energy efficiency rating. It's an acronym. The higher the number, the more efficient the system is going to be. These systems, for example, are 16 SEER systems. So they're on the medium to high side for energy efficiency. Most systems that are out there, if you've got a 14 SEER, a 12 SEER, or if you have a unit that's probably over 12 years old, you might even be down to a 10 or an 8 SEER. So those are going to cost you money when you run them through the summer. I want to say probably the number one thing when we talk about looking at your system and doing some troubleshooting is looking at your filter. So your air filter. If you haven't changed your air filter, that should be your number one issue to go take a look at. Your air filter is always located on the return ductwork and the return boot attached to the side of your furnace. So if you're not familiar with that, you should go take a look, because replacing your filter could save you $300 from having a service tech come out and tell you that, oh, you just have a dirty filter. Let me fix that for you. But along with that goes the cost of the filter, the cost of the truck and trip charge, and the cost of the 1 hour to be out there. So why is this important? 2 words. Critically important in both heating mode and cooling mode, airflow. If we don't get enough airflow over this coil, because this is full of pet hair, dog hair, cat hair, lint, dust bunnies, if this is full and we're not getting enough airflow over this coil turns into a giant block of ice. It literally turns into a giant block of ice inside here. When you pull that filter out and you let that system run, that block of ice will actually thaw pretty quickly, produce a lot of water. But airflow, and the same thing applies in the winter. When you're in heating mode and you're heating your house, if you don't change your filter, if you don't have enough airflow through here, what's going to happen is inside this heat exchanger, we don't get enough air through here, the temperature rises inside the heat exchanger because we're not moving enough air fast enough, and what happens is the heat exchanger has a safety high limit switch. It's usually set at about 160, 170 degrees, and if we don't get enough air through in both winter or in heating, we're going to have problems with either the furnace or with the A coil. So to summarize what those points to look for, number 1 should be your filter. That should be the first thing you look at. Number 2, check your batteries and your thermostat. Number 3, check your fuses, your breakers. Number 4 is going to take you outside to take a look at your contactor, your capacitor, and your condenser fan. So taking a look at these components in that order, you should probably be able, I would say within 50 to 60% of the service calls, take care of those items first. If you can solve those before calling a service tech, generally you'll be in good shape. So just being able to identify any of those issues And if you have the capacity, or you have the capacity, or someone you know can swap out a part for you, can save yourself a bunch of money.
You want to talk about like cottonseed and whatnot?
Yes. So cottonseed is an HVAC tech's best friend. So we're all familiar with cottonwood trees. They release massive amounts of cottonseed. Where does that cottonseed get sucked into? Gets sucked into that compressor condenser. And it causes problems. So I would say, in addition to that filter, as I talked about on the inside, oftentimes this will turn into a big giant fuzzy filter on the outside. I have serviced clients in the past where they live along lakes, or they live along creeks or heavily wooded areas, and sometimes we have to go out and clean those condensers 2-3 times a year. It is just so ridiculous how much cottonseed those pull in. So if you do see the fact that you have a bunch of cottonseed, or you have a fuzzy blanket growing on the outside of your coil, you can shut your power off, your disconnect. You could take a hose and you can spray from the inside to the outside. I want to be very clear. What we don't want to do is we don't want to drive the dirt, the cottonseed into the coil. We want to drive it from the inside out. So getting a hose, getting a sprayer, and spraying around will do magic, will do miracles. Or if you're so inclined, you could pull again the 5/16 screws on the cage that covers it. You could take a dry brush. You could get all that stuff out there.
Straight from the inside out, you gotta pull the top and the fan
Pull the
off.
top off.
Yep.
To the fan and just spray it.
Use air.
You could use air too, yeah. What you don't want to do, you don't want to bend the fins on these coils. So if you come in closely at some point, you can take a look that these condenser coils are surrounded by a bunch of fins, and the fins will fold over very easily. So make sure that as you're cleaning it, you're not damaging the fins. If you fold over fins, they do have a tool, it's called a fin comb. You can straighten out the fins. Otherwise, again, just making sure that that outside condenser coil is clean, making sure that your inside filter is clean, are the two biggest things you can do right off the bat, service-wise.
You have to comb your fins. I mean, there's always some bent. Brand new, there's some bent.
Yep.
At what point do you take the time to comb them straight again?
When you probably have a patch that's maybe the size of a fist, I would say that would warrant, taking a fin comb and straightening those out. If you took a thermal gun and you were to put it on a condenser coil outside, you could actually see the hot spots where those fins were bent over, because they're just not able to reject heat. And remember that fan on top is blowing heat upwards. So it is literally sucking everything from the outside in through that coil and then up. And generally, most households, probably you're looking at once or twice a year having those coils cleaned. But again, it really depends on where you live, what type of an environment you live in. Even just keeping those clean will increase your efficiency, your cost of your air conditioning substantially. So keeping those fins clean so that compressor doesn't have to do extra work is going to help you save some dollars in your AC bill. All right, what about questions?
If you have a dirty filter in the winter and the high limit does trip out, is that auto reset, or do you have to find it and hit a button?
Good question. It is auto reset.
Okay.
Yep.
Just in newer furnaces, or they all?
Most all of them. Good question. So the challenge that people have is they might have a dirty filter. That unit might run for, let's say, 5-10 minutes, and it might be a shoulder season. Okay? So maybe the outside temperature is 40-50 degrees. The unit's going to heat up. It's going to blow some warm air for a short time. Then it's going to reach the high limit switch. And then the unit's going to shut itself off on a safety, because it's going to protect itself. Then, once that limit switch cools, there's a restart cycle. So it could be running in the background your entire heating season and you not know it. The way you would know it is because you're not getting to the set point on your thermostat. So if I'm setting my thermostat at, say, 72 degrees and it's taking hours for it to get there, odds are you probably have a dirty filter, and odds are your high limit switch is going off and it's shutting your unit down. Then when it cools, it restarts, it runs again. It might run for 5 minutes, it might run for 10 minutes, and then it shuts off. So it's going to do that cycle continuously. And there are other safety features inside the furnace that are manual resets, rollout switches, some high limit switches in different places that do physically require a hard reset. But the high limit switch will reset itself.
Buttons for those resets?
What's that?
The ones you have manually, there must be a button in there.
Yep, there's a little button. It's a bimetal disc. It's 2 different pieces of metal. It's about usually the size of a thumbnail, and that bimetal disc has a piece of metal that when it heats up, it pops basically, and it breaks contact, and the unit doesn't have a complete loop on its low voltage side, so the unit shuts down. And then yeah, there's a little button that pushes the bimetal disc back into shape.
Is there a problem with a bunch of water going into the condenser? Like if you didn't have gutters on your roof or whatever?
Good question. So it's not ideal that the compressor condenser be underneath a waterfall, but they are built as outdoor units. They can take quite a bit of snow, they can take quite a bit of rain. There are electrical compartments, there are electrical parts in here. They are behind a cover. They are somewhat weatherproof, but ideally, if it's constantly getting water on it, you might want to look for either a different location or some sort of a cover to put over that, a shed roof, but it's got to be pretty high. I mean, realistically, we don't want to do anything that's going to restrict that airflow coming off the top of that unit. But good question.
Go ahead.
Do you recommend covering them in the winter?
Not necessarily. They make covers for air conditioners. I think what I've seen mostly in the city, people will cover them just to keep kids and vandals out of them. There was at one point kids that would run around and stick a bar or a stick through the top, and then it would stop the fan motor from running, burn out the fan motor. But I would say you don't necessarily need a cover on it.
Mice would probably love that.
Mice would probably love that. A nice, conditioned, somewhat warm place for them to live in, sheltered from the snow and the water. Yeah. Yeah.
Actually, another thing that's a common problem is mice love to sit right in here, and like sometimes their nests can block this contactor. So sometimes you don't even have a bad contactor. It's just mice poop and.
I pulled a squirrel out of my last one.
Yeah.
I electrocuted him. I taught him. If you got a spot in your house that's not as cold as the rest, and you close a bunch of vents in the rooms that are getting too much to try to dump it all into the one, then you just kind of freeze your A coil up.
Good question. So that's
How do you fix that? And get it
well, that's a duct design question. So the question is, let's say for example, I've got a 3-4 bedroom home, and let's say that my kitchen is always cold. And so I'm going to run around to all my vents, my forced air vents on the floor or the sidewall, and they've got OBDs, opposed blade dampers, so I can shut them down. What's happening in the big picture of your system is you're actually slowing that air. So whether it's a return or a supply, once you start to slow that air, there is a fine line between how much air is going over that coil before it starts to affect the high limit switch or before you start to make an ice cube. So you do need to be careful to an extent. Obviously, if you do it and you realize you're having a problem, you can go back, you can correct the registers of the dampers, you can alter those. Your system will shut down. You probably want to shut it down for an hour. And then once you make those alterations back, you can go back and kind of fine tune the system. So what you're talking about is more along the lines of air balancing. It's a process we go through on a new home, new construction or a building. And when the register says it needs 150 CFM, there's an actual tool device that we use that measures airflow. And we dial in all the different registers to make sure we're getting the correct airflow. And a big part of that too is to make sure that we're not restricting airflow over those coils or heat exchangers.
How important is it to have your vents clean?
Good question. I'm asked that all the time, and I think the answer really comes down to, what type of use is occurring in your house in terms of occupancy, in terms of cats, dogs, in terms of kids. Floor registers, especially the returns. If you have a return on a floor, it's going to pick up a fair amount of everything that crosses the surface of your floor. That includes marbles, that includes toys, it includes fur balls, dust bunnies. Every time if you're sweeping while your system's running, all that stuff's going to get sucked into your ductwork system. So I would say, realistically, if I were buying a house, a new house, or a house that was existing and there was occupants in there, it's probably a good time to consider maybe just cleaning the ductwork out because, realistically, everything going through that system is what the former occupant had running through their house. Another thing I think I want to point out too is about, overall the duct construction, the configuration of the ductwork in your house is air sealing. Probably the biggest advancement in our trade in the last 15 years has really been sealing the joints and the connections in your ductwork. If you go down to your basement and you feel around the A-coil, the plenum above it, and you've got hot air or cold air coming out of it, depending on the season, if you're losing air all over your system, it's really not supposed to do that. And the reason being is we think now of airflow basically along the lines of plumbing. We want the water to get to the fixture where it's supposed to come out. It's the same theory that's now treated on the air side, which is we want the air to come out the register, not in the basement, not in the walls, not in the ceiling. We want the air to come out at the register it's supposed to. And generally when we talk about energy efficiency with systems and air duct leakage, we know that 25% of the air loss that occurs in a residential system occurs within the first 10-15 feet of the furnace. So basically the trunk line, I know Dan, you've had a lot of fun constructing that in the last couple of months, but your trunks and your branches, anything where you've got air coming out, you want to get that sealed because you want the air to go where it's supposed to. And especially when we talk about older homes in the city, those return, if you've got, for example, an unfinished basement or you've got an older home or the basement's not used and maybe you've got water intrusion or you might have a small mold or mildew issue in your basement, you're sucking all that return air from the basement through all those leaks and all those cracks into your air system, and then you're redistributing it through your house. So as a good practice, sealing the ductwork, I'm a big fan of the duct sealer, the actual we call Pookie or Mastic by its trade name. I'm a big fan of the Mastic, not so much on the tape, just because tape often, it really comes down to the quality of how the tape was applied, and tape can often also dry out sometimes. That's why in the HVAC trade we never ever use what? It's gray, comes on a roll. Duct tape. And I got to get a kick out of it because when I go to the Home Depot here, in the ductwork section is the biggest variety and section of duct tape you've ever seen. And I will reiterate again, it is against code to use duct tape on ductwork. So don't ever put duct tape on your system.
You know that when they originally invented duct tape, it was D-U-C-K, duck. Because it was a waterproofer.
Yeah.
What it was for military ammo boxes and stuff. Then it changed to D-U-C-T somewhere along the line.
Somewhere along the line.
You'd fix everything with duct tape except ducts.
Yes. I don't think I've used or touched a roll of duct tape in probably 20 years.
Might have turned in your man card.
If I do the job right, I shouldn't need duct tape. All right, what other questions we got?
Would a dirty filter still warrant freezing on your lines in the exterior of your house?
Yes, it can. Yep. Because what we're doing is we're slowing down that air going through the A-coil, and the A-coil now is not able to really pick up all that heat. So we're getting an inadequate phase change. As that refrigerant hits that metering device, it changes from a liquid to a gas. And there's a sweet spot in that A-coil where it does the phase change. It increases the BTU capacity significantly. And if we start to restrict that process, if we start to restrict where the phase change occurs, or if the phase change occurs at all, because again, we're not putting enough hot air over that coil, then you can see basically a lack of a phase change as it goes out to the suction line. So yeah, I mean, the easiest thing, filters, filters, filters. Change the filters.
You have a blue filter there. Is that the kind of filter you recommend over like the pleated style?
Good question. So I consider these kind of construction filters. These are just really kind of a light media filter. I would not recommend these. Spend a couple extra dollars and get what's called the deep pleated media filters. And they make them in 1 inch, they make them in 2 inch, they make them up to 4 inch. And you'll know, because when I say pleated filter, you'll see it's basically a filter media that is pleated, and they do that to get more surface air out of your filter. I would be careful. I know some people like to really go to the extreme. They like to get like a MERV 14 or a MERV 20 or even a HEPA filter on their system. These were not designed or engineered for HEPA filters. They weren't necessarily designed or engineered for super high MERV filters. And again, MERV is another acronym that's used to describe the quality type of the filter. The higher the number on a filter is the more restrictive the filter is going to be. So in reality is if you're using a high MERV filter already, your lifespan might be quite a bit shorter depending on, again, the amount of traffic and usage of your house. Generally, I like anywhere from a MERV, maybe a MERV 8 to a MERV 11. You can find those at most of the big box stores. I will tell you, watch out if you're getting a new system installed. Watch out for the contractors that sell you their proprietary filter system. And what I mean by that is they will install or replace your media, your filter box, and they'll give you their special deal. Now the problem with their special deal is you'll never get access to that filter yourself, whether online or at a hardware store or at a big box store. Because what they do is they make an odd size on that filter. So what that means is it now marries you to that contractor literally for life. Every time you want a filter, you have to deal with them to get that filter because it's an oddball. It might be a ½ inch undersized or a ½ inch oversized, or it might be an odd number. So again, that's only going to occur if you have a new system being installed and a contractor convinces you to go with their special filter.
Can't you just fold the filter and do some duct tape so it slides in?
Kevin, I bet you could do that, yes. As long as the air doesn't pass over the filter or around the filter. I've seen some pretty creative filter installations, and you know, some people do what works, but
Electronic filter worth it?
good question. Electronic filter. So electronic filters were popular about 20, 25 years ago. I don't think I've installed an electronic filter in probably 15 years. The reality behind electronic filters is it creates a polarity change as the ions pass through the electronic filter. They're attracted to the plates due to an electrical charge. The challenge is it works great for the first month, but then as more and more dust starts to build up on that electronic filter, what happens is it becomes less and less effective. The careful thing to watch out for with electronic filters, again, you're going to see these on mostly older installations, older houses, is that once you do clean them, they will snap and crackle quite a bit. And what that's telling you is that the little wires that are in the filter system itself are too close in contact with each other, or they're too close in contact with the negative ion producer that's being generated by the charge. So they're real finicky. Most electronic air filters that I run across, I take them out, and amazingly, it's a direct retrofit swap for a deep pleated media filter to go inside of it. So I just take basically the two cores out, get rid of them, and then put in a whole new pleated media filter. So another thing probably too important for people to understand is the newer systems, I should say furnaces. The newer furnaces are designed to run a lot more often and more frequently and longer than your older systems. With the technology that's out there today, with the ECM fan motors, electronically commutated motors, they're going to run at about 75% more efficient than a split capacitor motor. And I know this is getting a little technical, but just know that most of your newer furnaces, that fan motor is going to run longer, it's going to run more often, it's going to be quieter, you're not going to hear it. But what that means is it's just circulating much more air through that filter. That's why these deep pleated media filters that you see in the big box store, they're about 4 inches thick. They need to be thick. They need to have deep pleats in them and catch as much air as they can and spread the volume of that collection out through those pleats so that those filters don't get clogged so fast. What hasn't been asked is how often should I change my filter? So I tell most people it depends on your usage. If you are using air conditioning a lot, you're probably going to want to change out your filters, I would say, minimum of twice a year. It also depends on how thick a filter you have. If you like to run your heat at 70 plus degrees, 72 degrees, 71 degrees, again, you're going to want to be changing those filters out at least minimum twice a year, 3 times a year. Filters are cheap considering what you can get for efficiency out of your system. The more those filters are clogged up, the more harder it is for that system to operate. Any other questions?
What about like condensation coming back out of the lines, drainage wise, and anything to look for in that if it's excessive or?
Yeah, I wouldn't say excessive. I would be more concerned if you're running your air conditioning and you're not getting any condensate out of there. So your system in this particular scenario is going to condense year round. So most of your high efficiency furnaces, you can identify them because they'll have PVC pipes coming off the top of them. That's telling you that you have a 90 plus efficient furnace. It's going to produce condensation through the secondary heat exchanger, and that's going to run out through the entire winter when you're running your furnace. When you're running your air conditioner in the summer, your A coil is going to produce condensate. And that condensate is going to come out depending on how high the humidity levels are outside your house. So on a day when you've got 90 plus degree weather, the dew points may be sitting into the 70s. I've seen these systems produce up to 5 gallons in one day in cooling mode in the summer. So 5 gallons, it's actually quite a bit of condensate. I've had some hardcore customers and clients that have said, well, I don't want to waste that water. What can I do with it? The condensate on your air conditioner, you can actually reuse, feed the house plants, do whatever you want with it. The condensate that comes off your furnace, you cannot. So do not take any of the condensate that comes off your furnace and try and reuse that for plants or recovering water. Because the process of combustion, as the gases change and are formed, produces a byproduct in the condensate that makes the condensate acidic. So just kind of keep that in mind. All right, so I'm going to recap real quick things to look for. Number one, we're going to look at our filters on the inside next to the furnace. We're going to look at our outdoor compressor condenser and make sure that that hasn't become a giant filter. I think the other thing too I want to also mention is, let's say you're that person that has a bad filter and you're like, God, you know what? I pulled it out, now it's working. It's working fine, but now I got to go get a filter. But I'm going to get it tomorrow. And then tomorrow passes, and now you're running your furnace without a filter, okay? Now all of a sudden a week goes by because now it's like, who cares? I got cool air coming out, right? Well, I want to point out that there is the potential for a second filter in your system. And this one's even more of a pain in the butt to change out. And that is the coils and the bottom of this A coil. So the bottom of this A coil, this evaporator, is another whole set of fins and coils that act just like a filter. Now, I have pulled hairballs the size of squirrels and cats out of these things because at some point someone decided it was easy enough to take the filter out and not replace it and then use your A coil as a filter, which it is not designed to do. And to get to this is not a fun task, is it, Dylan? No. Basically, you're having to tear apart and separate your A coil from off the top of your furnace, which is usually trapped by a whole bunch of sheet metal ductwork on top of it. It is not a pleasant, fun task to do, but I have often seen these just completely impacted with dirt, debris, fur, you name it. All right, so filters, compressor, condenser, checking the coil on the outside. As I mentioned, your batteries, and then also we're going to move outside and we're going to look at the condition of our outside unit. Is the condenser fan running? If it's not, but you hear the compressor running, odds are you've got a bad condenser fan motor, or it could be the capacitor. I guess I didn't tie those two things in. This is directly related to the operation of your condenser fan motor. So you could either have a capacitor that's blown and it's swelled up real big. Replace that. Most likely your condenser fan is going to go back and start running. We talked about the contactor. The contactor that's chattering, that's time for a replacement on the contactor. And we also talked about the suction line set here that goes in, whether it has frost built up on it or whether it's warm. And ideally, on an R22 system, we want to feel for that beer can cold. On the 410A system, it's going to be not as cold, usually looking at return temperatures at about maybe 50, 60 degrees. So with that being said, just a couple of things that you can look at in your system. If it gets down to you start to see frost on your vapor gas side, you need to call a service tech. If you've gone through and you've replaced a part and it wasn't the magic part, most likely you probably at that point want to call a service tech. Anything in between, your batteries, your filters, cleaning the outside compressor condenser, checking to see that you've got condensate coming off your unit, checking those things can save you some money. So if there aren't any other questions, I think we'll wrap it up. All right, now you guys know everything that we know. Thank you. Yep, thank you.